The work we do here at Ohio State in experimental hypersonics is making a national impact. My name is Jesse Little, and I'm the director of the Aerospace Research Center at Ohio State. I also direct the Experimental Hypersonics Lab. We study experimental hypersonics, so hypersonic flight is objects moving more than 5 times the speed of sound. Experimentally, this is a difficult problem to study because you need to produce airflows that are that fast, but also at the relevant conditions that you might see in a flight environment. Here at Ohio State, we have one of the more unique facilities in the country to do this. Behind me, this is the Large Area Reflected Shock Tunnel. This is the largest university-operated hypersonic tunnel in the nation. Most of the university-scale research we see is in smaller scale facilities on the order of maybe 6 inches or less in terms of wind tunnel size. This one is 45 inches in diameter, so substantially larger, and this allows us to study things that are nearly full scale or even full scale in some conditions. So what that means is the actual vehicle that might be flying in the atmosphere can be tested here before it goes and flies. That permits us to study the real problems that you might see in flight and not have to just infer them from a small scale. This tunnel operates at Mach 6, 7, and 8, which is a capability that is somewhat unique in a university environment. This facility has been at Ohio State for about 30 years, but it's only been used for gas turbine testing until the last year or so. We basically resuscitated or modified a few things related to it to allow us to do hypersonics testing. Now that we've really hit our stride and are able to do hypersonic testing here in this facility regularly, that's really been exciting to see that facility come online. It's been exciting for the country as well. We have a lot of interest in this facility around the nation just because of the scale and capability we have here. One of the things we've really been spending a lot of time on now is understanding how this facility operates. This is a shock tunnel, which is not a conventional wind tunnel facility. It has a bit more uniqueness in how you run it and the types of flow fields you can get out. So we've really been probing these flows significantly over the last year or so to understand the facility and what kind of airflow we're producing and make sure that it's really giving us the type of conditions we want to see in flight. Some of the recent results we've shown is that the flow in the tunnel is really quite excellent, even more so than we had expected. Sometimes in hypersonics you sacrifice the quality of the flow just to get the right conditions, and so far we've seen here not only is it producing conditions that are relevant to the flight environment, but it's also producing a high quality flow field that's suitable for basic research and not just more applied testing. We do a lot of fast response measurements, so the facility, while it is large and very capable, runs for only a few tens of milliseconds at a time. So any of the data we acquire has to be acquired quickly. So we have very fast response surface measurements. We also do a lot of optical measurements using fast response cameras, very high-speed imaging, and all those types of things allow us to study information about the flow field. Because these flows are moving so fast, we really have to slow them down to understand the physics of what's occurring. A big component of what we do is training the workforce. There's a dearth of workforce in hypersonics right now, so we're trying to train up students to take the place of many of those who have retired over the years, and being able to train them at scale is very important. We want to continue to push the boundaries of what we can study here with this facility. We're really only scratching the surface. The hypersonic capabilities and expertise here at Ohio State are really some of the best in the nation.